All right. Polynomial and polynomial-like equations, okay? In one variable, okay? So jumping straight in here, quadratic equation in one variable, say the variable x, okay, it can be any variable, don't get hung up on just one thing, okay? Is an equation that can be transformed into the form ax squared plus bx plus c, okay? Where a, b, and c are real numbers and a cannot equal zero, because if a ends up equaling zero, look, it just turns into a linear, okay? The power of two. Such equations are also called second degree equations, as x appears to be the second power. The name quadratic comes from the Latin word quadrus, meaning square. Okay. So note, while this mentions second degree equations, any degree above one, okay, notice how this thing is equal to zero. Okay. And we do that specifically because of that guy right there. But like I said, anytime it's any degree above one, you always make it equal to zero. Okay, no matter what it is. I don't care what it is, period. Other than that, okay, and like I said, anything greater than one. Okay, everybody good with that so far? You've done that, you've done that. Okay, let's see if we got anything else here. We kind of need to. Let's see here. Okay. I want to make sure because I want to look at my notes, make sure because sometimes I put really important things right here at the beginning of the notes. Let's look at a couple of quadratic equations. Okay, we'll look at the first one. Okay, notice it has x squared plus 5x over 2 equals 3 over 2. Well, the first rule is always to get it to zero, but technically speaking, I always like to get rid of the fraction first. Okay, which means I'm going to go ahead and multiply everything by 2. Now, for the sake of time and because of who you are at this point, just assume moving forward, anytime you see a fraction, unless I state otherwise, I'm going to jump right in and just start removing the fraction. Okay. So on this one right here, I'm going to automatically come in here and around every single term, I'm going to multiply by a 2. Okay. Here that will divide out to a 1 and divide to 1. I don't know what to fix that. Right. Okay, and then I'm going to rewrite very carefully. And so I have 2x squared plus 5x is all equal to 3. But then we know the rule is because anytime we see that power of 2 pop up or anything greater than a power of 1, it's automatically going to equal to 0. I say automatically, yes, we have factoring rules later on that you might be able to skip a step because sometimes we might move stuff back, okay? But right now, let's just kind of remember where we're at. We'll deal with that, anything else like that later on, okay? So here, I'm going to go ahead and just rewrite this with that 3 on the other side. So I've got 2x squared plus 5x minus 3 all equal to 0. And then, of course, at that point, you're at the AC method again. Okay, because you're going to factor. Remember, you're solving now. Okay, so we're not factoring anymore. We're solving. Okay, so we haven't got to the quadratic formula again yet. So we need to remember that if it's not factorable, it's fine. But right now we're solving. Everything is solvable for you because of the quadratic formula now. Okay, but for this one, we can use the AC method. Remember, we've got A times C. That's going to just give us a 6. We think of all our factors of 6, which is 1 and 6, and then what? 2 and then 3. And then you don't need to keep going because what's going to happen? They're just going to flip around, right? So you don't need that. Good review. What does this say there?
Different signs.
Different signs. The larger one's going to be what? Very good. So we come in here, make that guy positive, make that guy negative. I cannot just put those back into the equation because I do not have a pretty coefficient of 1, leading coefficient of 1. So I have to put everything back in so I can factor by grouping at that point. Okay. Some of you may have learned the guess and check method. I get it. I don't really use the guess and check method. Okay. So we're going to come in here, put everything back together, and then notice Which one am I gonna be using?
And 6.
Exactly, the 1 and 6, I'm gonna put a little plus and minus there. Yeah, it's because you can do the math of that real quick. -1 plus 6 does give me a +5. -1 times a +6. Okay, we'll work out whenever we get all the other stuff done. Can't do that right now, doing it like a pretty coefficient one, you can't do it that way. Got ahead of myself, started thinking too fast. Okay, so we rewrite. I have 2x squared minus x plus 6x minus 3 all equal to 0. Does it matter what order I put those in right there? No, those can go either way. Doesn't matter. You can put the +6 first and the -x. Doesn't matter. It's always going to work out. Okay. Come in here. Let's go and factor by grouping. Let's come in here. Start grouping everything. Notice in this first one, I can pull out an x. Okay, that's going to leave me with what? 2x minus 1. Notice on the next one, I can pull out a what?
3.
Yep, just a 3. When I divide everything over here by 3, you're going to once again get 2x minus 1 again. And that is a very good sign, right? When everything starts to match, you know you're on the right trail. Okay. So then we finish our factoring here. So we've got x plus 3, 2x minus 1, all equal to 0. But are we done? No, we're solving. Other than the fact that on the test, I'm going to tell you to solve. But what's a telltale sign that you're solving?
The equals.
Yeah, look at the equal sign. You see the equal sign, you're solving, okay? Down here, draw your line. You've got x plus 3, all equal to 0. Then you got 2x minus 1, all equal to 0. Solve everything, and you're going to get, I'm going to put up here at the top, x is equal to -3 and what? 1/2. So there's our answer right there. And all we did right there, we just solved for x on both of those bottom ones right there. Kind of good little review, right? Okay. Why don't y'all do the second one real fast and I'll play catch up. Once again, go and keep working if you're working. I'm going to start kind of playing here. I'm going to rewrite this equation in the proper form with it equal to 0. Don't get full, there's a variable over there, so you need to make sure you put everything in descending order. Notice here, AC method again. Positive symbol, same signs, both negative. This one gets to be, the one, when you have a coefficient of 1, you can kind of make it easy on yourself, because really, you can just automatically come in here, can't you? And just do that automatically. And since you've got that coefficient of 1, you know you're going to have an S in both of them. This one has same signs, so you know both of those are going to be negative. Now you just need to find something that's going to multiply to 6, or sorry, add to 6 and then multiply to 9, which is obviously going to be 3 in both of them. Anybody tell me what that is? See it before, it's a formula I'm showing you.
Difference of square.
Difference of squares, you'd see this right here. Remember, there'd be a plus in there somewhere. Perfect square trinomial. Remember, whenever you're creating perfect squares, you always got that s squared or something squared. Okay. So notice you would solve this one. Okay, you still have to solve it, but you have to put down the number twice. Okay. you would just do the s minus 3 is equal to 0, and then you would get s is equal to 3. And that would be your sole answer, okay? It's what we would call a double root, okay? If you go back in time to whenever I've taught you before, that would look something like this. Because I know this is a positive quadratic, I know that its vertex is sitting at 3, and it would look like that. Okay, so notice it sits exactly on the X line. It doesn't drop beneath it where you're getting those two answers, it's just sitting right on top of it. That's why it does that, okay? Don't worry if you don't remember that, because guess what? You're gonna get all kinds of factoring. Or all kinds of graphing in this class. All right, solving perfect squares. Let's look at that. Let's kind of go back in that. That would be back in time, this would be chapter 16. Okay, if we were in the previous class. Notice the shape of the formula. Okay, you have something squared and it's equal to something. Now, back in time, if you were just learning how to factor, you would have had to break apart that expression, FOIL it together, or use the formula of perfect squares to kind of put that together, and then make it equal to 0, right? The only problem with that is this. Because that's a factoring method, you may end up at a situation where you can't factor it, okay? Or, in this case, you can go, okay, well, I'm gonna have to use a quadratic formula, which is just fine, always. But if something's already in a form that's kind of like gifted to you, use this other method. So notice I have a square on one side, nothing on the other. So look at it carefully. How do you get rid of a square? How do you get rid of a power 2? Do what?
You put it like 2 times.
Square rooted.
Oh.
Square rooted. Remember this. To get rid, let's write off here to the side. I don't actually, I don't add this to the notes. So this is gonna be for you being the video. If I have a square, so we're just gonna say x squared, and I take the square root of that, notice there's actually a 2 there. Well, how many times will 2 go into 2? 1 time, and so you just get x. And that works for anything. So notice if you ever want to get rid of a power, raise it to the radicand or the radical with the same index. If I want to get rid of a cube root, raise it, or I want to get rid of a power 3, raise it to a cube root. If I want to get rid of a power 8, raise it to the 8th root. Or sorry, take the 8th root. But notice the opposite also applies because these are inverses of each other. Okay. So if I want to get rid of a square root, what do?
To index.
Yeah, match the power to the index. And once again, it works. If you change those powers over into fractions, you'll see why the math works out. Okay, remember when we kind of did that back whenever I taught you how to do fractional exponents? Everybody hated so much. But that's why the math works. So let's look at this one. Instead of boiling this guy out, how about we make it easy on ourselves? And let's just do this. Let's take the square root of this side. But what we do to one side, we have to do the other. But what is one telltale thing that I told you last semester you got to have the muscle memory to do, or it says it up here. The moment you take the square root, remember that plus or minus? You got to have that plus or minus guy pop up right there, okay? Because you're still dealing with a quadratic. Okay? That power 2 tells me, literally, hear me out carefully. That power 2 states explicitly, at most, there can be 2 answers to this. Okay? That's what that 2 says. And so that's why I'm adding in that plus or minus. It does not mean you're going to have a positive answer and a negative answer. That just means when you do the math for it a little bit, you're going to get 2 answers. Okay? Now they both might be positive, they both might be negative. We don't know what's going to happen yet. But that's what's going to happen. You'll learn about that law later on around in chapter 5. So let's finish this off. So notice what happens on the one side over here. When I take the square root of a power 2, that just goes away and you get 2x plus 3 is equal to plus or minus the square root of 8. Anybody look at that square root of 8 and tell me what's wrong with that? No, there's not a negative in there, you're just fine. It's gonna be where you get a blue bar on Hawk, and it's gonna make you mad.
It's not simplified.
It's not simplified. Okay, so you gotta come over here, so I'm gonna take that, I'm gonna write an 8 up here, and notice 8. Well, couldn't I turn this into 4 times 2? Remember that? And then we can come in here and take the square root of 4 times the square root of 2, which turns this into what? 2 root 2. Good news, your calculator does that for you. Okay? If you don't know how to do that, I can show you. Okay? You have to change it over to a different mode, but it will do it for you. Intermediate, I didn't allow a lot of that because I want to know that you know how to simplify. And you still need to know how to simplify because guess what? Your calculator won't do cube roots or fifth roots or sixth roots, and we're gonna be dealing with a lot of those. Okay. So I'm gonna go ahead and rewrite that in simplified form, and I got 2x plus 3 is equal to plus or minus 2 what? Root 2. Okay, well now what do we gotta do? We gotta go ahead and start getting everything moved over now, don't we? So let's start taking care of this. I'm gonna go ahead and get the x by itself, right? Isn't that the rule? So let's come in here and subtract 3 from both sides. Keep our rewriting going. 2x is equal to negative 3 plus or minus 2 root 2. Then I'm going to go ahead and divide off that 2. This way right here, and I get x is equal to negative 3 plus or minus 2 root 2 over 2, but there is a problem with that. You would once again get a blue bar from Hawks. Remember that standard form I taught y'all? Where you can take that denominator and split it. If you have the same denominator, which in this case is a 2, there's only a 2 down there. You can split that up, and then look what's going to happen when I do that. I get negative 3 over 2 plus or minus 2 over 2 root 2. And then look at that 2 right there. This right here, does that not just reduce out? And so my final answer here is going to be where x is equal to negative 3 over 2 plus or minus the square root 2. And that's your final answer. Which is why I told you, splitting things up like when I taught you on complex numbers is not something you only have to do in complex numbers. You can do it whenever you have fractions happen like this, especially when we start dealing with the quadratic formula, which I believe is coming up like right after this one. But when you do it, it makes it a lot easier to see how the fractions should reduce out. And where it gets really a lot better is whenever you have even numbers happening all over the place. Like if you had something weird there, sometimes people will just like reduce out. But remember, that's a little trinity of reducing if you're not careful. Okay. So just gotta be careful with some of that. Okay, good. I don't want to go too fast. If you're, I mean, a lot of this is still review, right? It's just the math is a little bit different. Okay. Problems are a little bit harder. All right. Take on with this. Completing the square. Completing the square, step 1, write the equation equal to 0. Step 2, okay, well, okay. We're getting rid of a step. When I'm teaching this to you in intermediate, there's like 6 steps. We boiled it down to notice just 4. Basically, step 1 is saying this. When you get it equal to 0, take that constant and put it back on the other side. Okay, so remember earlier when I said, hey, get these things always equal to 0? Well, yeah, that works, unless you're going to go in there and start completing the square. Now, I still contend, and now Hawks is going to give you some ugly ones, I get it. I still contend every once in a while that maybe you should come in there and go, I'm not going to complete the square if certain things happen, and I'll show you what I'm talking about shortly. Because if things start getting too ugly, I'm always of the frame, I'm like, man, that's too many moving parts. I've got the quadratic formula I can go to. You know, where he's always kind of my safe bet. You know, where I don't have to think it's hard. And I mean, I don't mind the thinking, but I just don't make sure there's so many moving parts I get lost. Okay. So notice step one, we're going to get the constant to the right hand side. Then we're going to divide off everything by a. Okay, square, and then put it back. Now they make it look really weird. So let me show you this in a very step-by-step easier way. Okay. Notice. Careful. We have a polynomial here, a quadratic. I know it's quadratic because it's power 2. First things first, 1, get the constant alone. Okay, so let's add 6 to both sides. Okay, so let's add 6 to both sides. And then rewrite. X squared minus 2x is equal to 6. Okay? For those of you who are afraid of rewriting, quit it now, because you're going to want to learn to rewrite. Now what it says is this. Look at your coefficient of x, not x squared. Okay, it's going to be this guy right here. Okay? You're going to take it, bring it down. Okay? And you're going to come in here and take this 2 and divide it by 2. Always by 2. You're always dividing by 2 because you're cutting it in half. Okay? 2 divided by 2 is obviously going to be 1, and then we square it. And then we get a 1, obviously. Okay? Now, what they are showing here at the front, let me show you something. So if you're kind of looking at this formula, like, what are they doing? Notice this has an A here. Okay? What they're saying on this one is this. You cannot do this method if there is anything other than a 1 as a leading coefficient. Okay? So what they did with this A here is divide it out. It's just, it's hard to see it being divided out whenever everything up here is a variable. Okay? So that's all they did. So like say this one right here that we're working on, say it had like 2x squared. I can't do that. I would have to divide the 2 amongst everything because I can only have a 1 out front. That's the only way this method works. Okay? That can help y'all kind of remember that a little bit. Okay. Now what we're going to do is we're going to take that 1 and we're going to add it back to both sides. Notice that's a 1. There's no variable attached to that thing. It's a constant. So I'm going to take this 1 and I'm going to add 1 here and I'm going to add 1 to the right hand side. And once again, I'm going to rewrite. X squared minus 2x plus 1 is equal to, well, 6 plus 1 is just 7. Okay, now here's the beauty of this. Now, first off, it's tough to see until you're used to seeing these, but believe it or not, this right here is a perfect square trinomial. It will factor into x minus 1, x minus 1. If you don't believe me, do the AC method on it. Okay, but it is of the form a squared plus or minus 2ab plus b squared. Remember I've shown you that before? It does fit that formula. That's what we were trying to create. That's how come we call this completing the square, is because on the left-hand side, we want something that's just going to factor nicely, which we have now created. Nothing factors better than this because you only get one answer. So notice, knowing this factors into x minus 1 squared is equal to 7. And now look what we have. What did we just do before this one? If you scroll back up, does that look any different than what we just did? So we're here, we're doing the perfect square, solving using the square root method. So once again, now we can come here, just take the square root of both sides, correct? One thing I need to remember, when I put the square root around the constant on the right-hand side, what do I have to add immediately?
Plus or minus.
Exactly, plus or minus. Okay, come in here, rewrite. I have x minus 1 is equal to plus or minus the square root of 7. Hopefully you can all tell that the square root of 7 cannot be simplified. 1, because 7 is a prime number. Okay, so it's done. So we're gonna come right in here, add 1 to both sides, that cancels out there. And then our final answer is going to be x is equal to 1 plus or minus the square root of 7. Good with that? In my notes, I do show you a perfect square trinomial again. I'll show you kind of an ugly one actually, and show you how you can kind of start seeing them. It is something good to see. Okay. As kind of review, even though we're not there yet, can anybody tell me what those points are? Don't tell me what the numbers are. I'm not asking you what are the decimal values, okay, of this, but what is this right here?
Vector?
Huh?
Vector or max? I don't know.
I'm gonna get 2 answers out of that, right? X is equal to this and X is equal to that, right?
Coordinates
Coordinates, okay, coordinates of what?
for the, do we have to plug into the equation that you just taught us yesterday?
Well, you could. But let's realize something, and like I said, we're not there yet, but I want you have learned this before. Realize that when we put anything in the form of ax squared plus bx is equal to c, plus c, and we make it equal to 0, what is that 0?
Why?
Sure, why? Well, let's think about this. I'm making y 0. Where is y 0? Always. Yeah, right there, right? So if y is 0, what is it saying x is? Remember these little coordinate points? If x is 0, if y is 0, then the x is going to be what? You're looking at that, right? Aren't you looking at points where that happens? That's what you just found. You found your x-intercepts. Okay, those are x-intercepts. When y is 0, those are your x-intercepts. Remember when you did slope? You're going to be learning here in a little bit in like next hours or a day. But still, remember whenever you're finding y-intercepts, what did you make to make a y-intercept? You made x 0. Remember, it's always the opposite. To find an x-intercept, make y 0. To make a y-intercept, make x 0. It's always the opposite. Well, here we made y 0. We found x-intercepts. Okay, why did you get 2 answers? There they are. Okay, is that going to help y'all kind of rejuvenating some like things that you lost over the last 3 weeks, or maybe even a semester if you haven't taken math in a while? Okay. Let's continue on. I don't want us to lose that fact because, like I said, in this class we are kind of graph heavy, and so the better you kind of start reacquainting yourself with the way graphs work, how we maneuver them, how we can start finding things about them really quick, the better. And then my old friend, the quadratic formula that I love so much. Just because, you know what? Dude, it's easy, bro. Who doesn't like the quadratic formula? Maybe the hardest part about the quadratic formula is remembering the quadratic formula, I guess. But good news in this class. For your midterm, you are not allowed any notes whatsoever. But for your final, just like I did for you in intermediate algebra, you are allowed a note card. I'll be giving you one, a little 3x5 note card that you're allowed to use. Okay. Give you a chance to move this over. Remember, the discriminant is the inside, okay, it's the radicand, it's the inside underneath the square root, okay? It's this part right here, and it literally just tells us what are we going to get? Are we going to get 2 real numbers? Are we going to get 1? Are we going to get imaginary numbers? Are we going to get complex numbers or non-reals? Okay, kind of lets us know. For our purposes, honestly, the reason I always do the discriminant first is I do this. Is my calculator actually going to give me an answer? That kind of makes sense. It's like, oh, Am I gonna get a real answer out of this? Or is it gonna say syntax error or domain error? Or, some sort of error because it was trying to give me a negative square root, which you can't have. Okay, so let's look at one real fast and we'll just kind of plug it in. Any of y'all learn how to do fractions on your calculator yet? Did y'all know these did fractions the whole time? Okay, well, they did. I just wasn't telling you that in intermediate algebra. They actually do fractions, they'll simplify fractions, they'll do some pretty hard fractions, actually. It actually gets quite amazing what these little can. I don't want you to get hung up on fractions too much, okay? So let's look at this one right here. I always, when I'm doing the quadratic formula, I always like to label everything. So notice I've got an A, a B, and a C. The reason I do that is because I'm the dumbest person I know, and I guarantee you I will look at something wrong eventually. So when I'm checking, I like to label everything. Rewriting my quadratic formula, just so we have it over here, I have negative b plus or minus the square root of b squared minus 4ac all over 2a. Technically speaking, it's x equals, okay? But you go with whatever variable they're giving you, okay? Remember, you're solving. So when you solve the quadratic formula, it's giving you two answers. It's saying, hey, or sometimes two answers, sometimes it'll give you one. But it's saying, hey, here's your x-intercepts, okay? So we come in here very quickly. Let's just start filling it in. Notice I've got a b, so let's do a negative 6 plus or minus 6 squared. I always put a parenthesis around that. Minus 4 times 1 times 13. And then we've got 2 times 1 is equal to. Oh, sorry, 2. Where'd my math today?
I put 0, so.
Yeah, but I haven't done that with math. I shouldn't be messing up yet. That didn't happen until later in the day. So let's kind of clear this out here. Notice what's going to happen if you do the math to the inside. You get 6 squared, that's 36. And then you get 4, let's see, 15, 13. So it ends up being what, negative 16? Okay. So you come over here. I'm going to keep going in this direction. I get negative 6 plus or minus the square root of negative 16 all over 2. Well, there's just problems with that all the way around. But what's their biggest problem right now?
The square root?
Exactly. Can't have a negative inside of a square root. So what are you going to do with that negative inside that square root?
Take it out.
Take this guy out, and he's automatically going to just become I. Remember that? Okay. And then I can take the square root of 16, can't I? What is it?
4.
Very good. So let's look at this very carefully. And I've got negative 6. And look what I'm going to do. I'm going to write it in standard form. Reason being is look what it's going to do. Negative 6 over 2 plus or minus 4 over 2i. Now I've got two fractions I just need to simplify, and I'm going to get what? Negative 3 plus or minus 2i. You might say, well, I didn't really need to split that up. And you're right, you didn't really need to, but sometimes, okay, you're going to get a different denominator. Okay, so you got to be careful about that. So that's like I'm going to say, just split them up until you just get really good at seeing those. Okay. How we feel? Good? Is there anything we've done that you haven't seen before? Everything good? Good, then let me make you mad at me. Because you're in college algebra now, they're gonna make things a little bit different, okay? So this is where you get the name of the lesson, polynomial and polynomial-like. Okay? Good news is you don't see these a whole bunch. Bad news is when they show up, you have to go, oh crap, I forget. And you have to go back and look at your notes. Okay? Polynomial-like ones are things that they're really close to being polynomial, like a quadratic, but they're just different enough to confuse you. So we have a way to fix that. Okay? So they look like this. Okay? They're a lot easier than you think, but let me kind of help you through them, okay? Because they got some moving parts, okay? So an equation is quadratic like, okay, or in quadratic in form, if it can be written out as a form. Look at how they wrote that. We're not using x's, are we? They use the capital A. Okay, they're doing that for a reason, because one, they don't want you to get confused between formulas. Where A, B, and C are constants, A can't be zero, and A, this big A, is an algebraic expression, okay? Such equations can be solved first by solving for A. You're just factoring. Normal factoring, that's it, okay? And then we substitute back in the expression, okay, that we substituted, okay? This will be one of those that once I do an example, you're gonna go, okay. I mean, it doesn't mean you're gonna like it, but you're gonna go, okay, I got it. So let's do one. And I'm gonna work you through it very carefully, okay? So let's look at this first. I'm gonna rewrite, so we can kind of work in order. I have x squared plus 2x squared minus 7 x squared plus 2x minus 8 all equal to 0. Okay, I want y'all to realize that I'm going to take this guy out right here, here and here, okay? So my A, I'll write it in blue up here, my A is going to equal x squared plus 2x. That's what I'm substituting now. So now when I do that, look at how I'm going to rewrite everything. So since I have a way to substitute this, let's rewrite the whole equation. And notice I just have what? A squared, right? Okay. Minus 7a minus 8 all equal to 0. Do you see that so far? So let me rewrite this beneath it in blue. If we just kind of had to write this as a normal quadratic, okay? You would literally just be seeing x squared minus 7x minus 8 all equal to 0. That's what we just did. But instead of using x, which we can't, okay, because x is a dedicated variable that we need to be solving for, we replaced this whole ugly thing with just an a saying, I know how to factor, I know how to solve when things look like this. This guy, I don't. So let me make it look like something I can understand. And that's exactly what we just did. So notice I'm going to factor it the same exact way. I'm going to erase this. And notice I'm going to go come here and do the AC method. Simple as that, literally. Simple as that. I'm going to say, okay, I've got A and C. Well, that's just going to become an 8, right? So let's think of all our factors. And I've got 1 and 8. I've got 2 and 4. Right? And then what?
The larger is 8.
Yeah, the larger is going to be, I've got to look at this and go, hey, I got different signs. The larger is going to have to be, okay, negative. So I come in here and let's check out everything. I got negative, I got a positive, I got a negative, I got a positive. Which one of these gets me to a 7? Obviously, it's going to be the 1 minus 8 gives me the negative 7. So now look how I'm going to rewrite this. I've got a pretty coefficient of 1, don't I?
Yeah.
Okay, well, let's rewrite it that way. Let's come back in here and look at, okay, I've got A plus 1. And then I've got what? A minus 8. All equal to 0. Good so far? Okay. Are you sure you're with me? Because this is where it might get a little confusing. I have an A already. I know what A is. A is this guy. You now put him back in. Okay? So look what's going to happen. I'm going to go this direction first. I'll put it in red so you can kind of see where I'm going. My A is going to be x squared. So notice I'm going to get x squared plus 2x plus 1 all equal to 0. if you look at that one very carefully, you should be able to tell that is a perfect square, because notice you're gonna end up getting x plus 1, right? So notice this turns into x plus 1 squared, all equal to 0, or basically x is equal to what? -1, right? And then you do it again here. I get x squared plus 2x minus 8, all equal to 0. That will obviously factor 2. You're gonna get an x in both. Okay. Different signs, larger one's positive, correct? How about 4 and 2? How does that sound to everybody? Everybody okay if I kind of start skipping the AC method just a little bit, just so we, okay? Notice you can go and check, hey, 4 minus 2 does give me the positive 2. 4 times -2 does give me a -8. That works. And so now I get x is equal to -4 and 2. And so the answer to this guy is all of that right there. And you're done. I would beg you to remember that this isn't hard, it's messy. Okay? You can do this, it's just gonna take some time to go, okay, there's some steps involved, okay? And to be slow, to be intentional, to be careful, take it step by step, learn to write clearer, okay? Good on that one? Let's do one more. Look at that fun one. I want you to look at it carefully, okay? And realize we can make this look like a quadratic formula, okay? Because it is very close, isn't it? I mean, look at it. You've got y to an exponent plus 4y to another exponent, all equal to something that looks so close. So why don't we turn it into one? Okay? This one, yes, can be a little weird looking, okay? So let's take a look at it. Okay, notice we're gonna go ahead and make our y cubed, okay? We're gonna turn him into a square. Now you gotta be careful with this. Okay? I'm pulling out, I gotta pull out a 2. Okay? I'm turning this guy right here into y squared. You cannot just turn that into y squared, because look, I'm trying to make that guy. I've got to have 2 of those. Because I can't have a equal this over here and a equal this over here. It's got to be the same thing. Okay, well, let's just remember, to pull a 2 out, you're factoring a 2, right? So in essence, I'm saying this. Everybody okay if I kind of write up above? I've got 2/3. I'm dividing by 2. Put that as 2 over 1. Well, remember, that's going to turn into 2/3 divided by 2 over 1, but we don't divide fractions. We multiply by reciprocals, right? And then look what we get. So whenever I rewrite this one down here on the bottom, you should be able to look at this and go, okay, so you're telling me I can write this as y to the 1/3 squared plus 4y to the 1/3. Okay, once again, capping that guy, minus 5, all equal to 0. I now have an a, right? So my a is going to equal y is 1/3. And so when I rewrite this, I've got a squared plus 4a minus 5, all equal to 0. Come back in here, pretty coefficient of 1. Got an a in both of them. Larger sign is going to be negative, then I'm going to have a positive. Everybody sees how I'm getting that right? Different signs, larger positive. Okay. How about five? Sorry. Five there. And then I will put my -1 right there. How about +5 and a -1? Because 5 minus 1 gives me a +4. 5 times -1 does give me a -5. And it would be at this point that you could go ahead and solve, but we can't. We've got to plug everything back in, right? Okay, well, let's do it. Very carefully. Notice I have a plus 5, but my a is 1/3. So let's do y to the 1/3 plus 5 is all equal to 0. How about we subtract 5 from both sides? Then you get y to the 1/3 is equal to -5. Problem is, somebody tell me something here. What is the another way we can write y to the 1/3? How many people remember that? When you have a fractional exponent, what is that actually? Remember that? You're actually looking at the cube root, okay? Remember, the index is your denominator. Your numerator is the power of the radican, okay?
The denominator?
Yeah, your index is the denominator, okay? And then that 1 is going to be the power. So it doesn't have to be a 1. I can have a 2 there, a 3, doesn't matter. Well, I can have a 3 on this one, but I can have a 4. That makes sense? Okay. That would be go back to 15.8 in your intermediate algebra. You can go through the YouTube channel, the thing in your syllabus. You can look there and look up 15, not 15.8. So I'm sorry, 15.5, somewhere in there. You'll look up radical exponents, or rational exponents, I would call it. So notice though, knowing now what you have, that y to the 1/3, realizing it's actually the cube root of 3, right? How do you get rid of a cube root? Raised to the power what?
3.
3. So to solve this part, I'm just going to raise this side to 3. And what am I going to do to the other side? Raise it to 3. I can't, you got to do one with the other, right? You're an algebra. And so this guy, notice, is going to turn into y is equal to, well, 5 cubed is 25. Okay, or 125, but notice you're going to have -125. Odd powers keep the negative, even powers lose the negative. And then we can do it again with the a minus 1, can't we? Come in here, I'm going to have y to the 1/3 minus 1, all equal to 0. We're going to turn that around into y to the cube is equal to 1. And then once again, we're going to do what? Raise both sides to 3. And then we get our final answer of just 1. And there's your answers. Did you see what I did with the y to the 2/3 power? I know that I have to have a 2. I've got to get this guy looking like a quadratic, which means my leading power needs to be a 2. So I just did some division there to pull out a 2, and then what's left? There it is. Okay. These are going to work out that these are going to match. Basically, that's what you're trying to do. Make these guys match. They cannot be different. Okay. So is this something you've seen before? Technically, but not. Okay. Let's see here. Any sort of hard, super hard homework? Let's go through a couple of examples. Try to do this one right here for me. Very carefully. It is different. while you keep working, knowing what I've told you about exponents and seeing that, how many answers should you have?
4.
4. Carefully. How about I divide on 16? You could have also taken the fourth root of both sides if you wanted to. Okay, that would have given you a 2 on the left-hand side. Okay, and a 3 on the right-hand side. Okay, remember, fourth root is just a square root twice. You take the square root of 16, you get 4, take the square root of 4, you get 2. So these are perfect fourths, okay, is what we would call those. I'm gonna do it this way though. So notice I divide off the 16, that reduces it out on one side, and then I'm left with a fourth is equal to 81 over 16. To get rid of a fourth power, I'm going to take what? Fourth root. Because this guy is even right here, okay? Now you've always done it with square roots, but anytime you have an even root, okay, you're always gonna have to make sure to add in your plus or minus. Okay? Notice when I do this, the 4 will go into 4 one time, so I'm left with just an A is equal to, and then I'm taking that, I've got to put that little 4 over there, girls. Boy, that does suck to do that in Hawks when you're doing everything correct and you forgot to do the little one to put the index down, and you're like, ah. And if you didn't use the right one, you got to go back and erase the whole problem and put the right square root button in there from the little, yeah, that's annoying. So notice I can come in here and take the fourth root of all this, and I get A is equal to plus or minus, well, 81, the fourth root of 81 is 3, and then the fourth root of 16 is 2, okay? There's 2 answers, but let me let you know that you have 2 more. You have plus or minus 3 over 2, guess what? I. You're always gonna have some imaginaries in there like this. Okay. How do I know that? How many answers did I just give you? Where are the other ones?
Plug it in. Oh,
They're not,
they're imaginary.
they're imaginary. Okay, the fundamental law of algebra says this: you have to have 4 answers. That was only 2. The other 2s are in the complex plane. Okay, can I help you on that one? That's how come I pulled that one off your homework, so that way when you see it, you can go, oh, okay.
It would have to be in fraction form. Because if you just took the fourth root of 16 and of both sides, instead of dividing off the 16 and stuff, you would have just had like 3,2.
Well, you would have this, look over here. If I take the fourth root off both sides,
Mhm.
this is what would happen. You'd come in here and go, okay, I've got 16, right? And then I'm gonna come in here, I've got this A to the fourth is equal to 81. Well, if I do this, if I take the fourth root here, I gotta take the fourth root here, don't forget your plus or minus. Fourth root of 16 is just gonna leave me with 2A is equal to plus or minus 9, divide off the 2. Sorry, plus or minus 3.
Okay, so it would have.
A is equal to plus or minus 3 over 2.
Okay, I skipped a step. It would have.
To help you, like I say, you can do it either way. Yeah. Okay. You good on that one? Okay, it's a confusing one, right? Okay, and it is one that even I had to kind of go back and realize, oh yeah, that's why. It's kind of a deeper thing, you gotta kind of remember, but that's how come I gave you this one right here to kind of show you a little bit, okay? Trying to see if there's any other, I mean, I've got a ton of examples here for y'all that you can look over. How about that one real fast? Let me work that one in class and then we'll get to the next lesson, okay? Tell me though, what type of quadrant, is this one of those polynomial like ones that you would probably need to look at? Yeah, look at it. you've got y plus 3, but then I've got 2/5 and I've got 7/5. Okay. Well, I don't like that at all. So let's take a look at it very, very carefully. This is a tricky one. I think I can list it this way. It's tricky but fun. Matter of fact, let me get dragging on my notes because it is tricky enough that it can kind of fool you just a little bit. Okay. So being very careful. I need to rewrite this in a certain form. Okay. Now I know my A. Okay. But let's look at this. You can factor something out. Okay. Remember in the last lesson how you were factoring out the fractions? This is why. We can factor out a fraction real fast. Okay. So let's look at this one. First off, we can figure out what our A is. Our A is automatically going to go ahead and just be that. A is equal to the y plus 3. Okay. But now I need to factor out, remember you're looking for, whenever you're factoring out, you're looking for the lowest power. Well, what's my lowest power technically? If I rewrote this as A to the 2/5 plus 4 to the 7/5 all equal to 0. What would be my lowest power? 2/5. Exactly, right? Okay, so I've got to factor him out completely. Okay, so I'm going to factor him out. Let's come in here, and that's literally dividing everything by what? A to the 2/5. No, you got to do that 2/5. Okay, so I'm going to come in here and divide A to the 2/5, and then A to the 2/5. Okay. Are we good so far? Okay. Rewrite. Be very careful. Okay, so I'm going to come down here. A to the 2/5 divided by A to the 2/5. Okay, now we know we're factoring right now, right? We're factoring out that GCF, which we know right now is that A to the 2/5. So when I'm factoring, I have to pull out this A to the 2/5. I'm going to put a parenthesis. Hey, A to the 2/5 divided by A to the 2/5 is just what? 1, right? And then I'm going to have a plus. Well, then we can come in here and look at this next part. What is that going to turn into? Well, I'm going to keep the 4, aren't I? And if you need to, look, you got a fraction here, a fraction here. You can come over here and go, hey, 7/5 minus 2/5 is going to equal 5/5, which is just going to equal what? 1. Well, anything raised to the power of 1 is what? It's just itself, exactly. So I literally right here just have what? A. All equal to 0. Well, hey, guess what? You just factored it. You just pulled out the GCF. That was the only thing you needed to do to factor it. We can't turn it into a power 2 because any way we could have turned it into a power 2 was gone after we pulled out the GCF, right? So now the only step that we need to do now is do what? Plug our original things back into it, okay? So let's take a look here and notice, coming in very carefully, let's look at this. Here. Okay. So we get 4A. So we're going to end up on one of these. We're going to have y plus 3. We're going to have to plug everything back in. So how about we've got this A, right black here, y plus 3 to the 2/5. Good so far? That would be one of them. Okay, and we're going to make that guy equal to 0. And then we have another one over here. We have y plus 3. Don't, I rewrote that wrong. There's a 4 out there. Don't forget that little 4 sitting in front. 4 y plus 3 all equal to 0. And then we can go ahead and just start the solving process. Okay. So coming in here very quickly, let's look at this first one here. Notice you have this 2/5. So basically, what's that gonna turn into? Look at it very carefully. Look, I'm gonna take this guy right here. I gotta rewrite it. Because that looks ugly right now. It kind of looks confusing on how to deal with it, right? So look at it, and I'm gonna turn this into the denominator is the what? Index. So this is gonna turn into the fifth of y plus 3 squared. All equal to 0, but to get rid of that, I'm just gonna raise everything to the power of 5. That's nice because why? That gets rid of that fifth root, and this just turns into y plus 3 squared, all equal to 0, which once again, I can just take the square root of both sides, can I not? And I get y plus 3 is equal to 0, and here I get y is equal to -3. And then we got to do it again, don't we? Okay, so let's kind of come in here being very careful. Look at this next one. I can go ahead and come in here and distribute that 4. I get 1 plus 4y plus 12 is all equal to 0. Combine like terms. 13, well, let's put it right. 4y plus 13 is all equal to 0. Subtract 13 from both sides. You get 4y is equal to -13, divide by 4, and then there's our other answers. So our answer is y is equal to -3 and -13/4. And you're welcome, since I did the two hard ones. I'm just joking. That's my job, I don't mind doing it. Plus it stretches my mind too, because I tell you what, sometimes I forget these. We don't really have time to jump into the next lesson, so let me do one more little quick example for you. It's a fun one. I always enjoy it. It's a word problem. All right down here. You'll see this one a couple of different ways throughout this lesson. A rock is thrown upward with a velocity of 27 meters per second from the top of a 23-meter high cliff, and it misses the cliff on the way back down. When will the rock be 11 meters from the ground level? Round your answer to 2 decimal places. Okay, they do give you a gravity equation when you look this up. Okay, like you can click the little button there and it'll give you an equation to look for. So let's look at this. I'll write it down for you. The gravity equation they're going to give you in Hobbes is this. Okay, is -1/2 gt squared plus v naught t is equal to h naught is equal to h. Well, just so you know, gravity, our force here on Earth, okay, is this. G is equal to 32 feet per second squared. What does that mean? I can replace that 32 in for G. Okay. And then you get a better looking formula that looks like this. You get -16 t squared plus v naught t. I'm sorry, I rewrite this over here. There's a plus symbol. I'm supposed to put that there. Sorry. I replaced that right there, just so you know what I changed if you weren't looking up. Plus h naught is equal to h. And then they notice they give us a whole bunch of stuff. Okay. We start looking for initial height, we look for initial velocity, and then we also have to look for initial everything else. So let's look at it. And then notice they say, hey, the initial velocity, that v naught is 27. So whenever you see that little subscript, this is what this is called, a subscript. It's not like a power. It's just saying, hey, at this time, this is what's happening. So at the 0th time, that initial, this is the speed. Okay? So h naught is 27. Sorry, v naught is 27. H naught, the initial height the rock was thrown from, is 23. And then we want to know when that rock is 11 meters from the ground. Well, if it hits the ground, how high is it off the ground? 0. We're not looking for 0, are we? We're looking for when is it 11 meters off the ground. Okay, that would be 33 feet up in the air. Okay, so all we do is we have to go, okay, well, when is h is equal to 33? Let's put everything into the formula now. Okay, so I've got negative 16t squared plus 27t plus 33. Oh, sorry, looking at my h, plus 23. And why did I put that? I told y'all 33, so please change that h into an 11. Don't listen to me. I'm thinking in feet, it's in meters. Okay, remember, because I told y'all 33 feet, that's how come I wrote that, so I apologize. Is all equal to 11. We should all know that this thing is not equal to 0 though, because even though they did say this, right, they said, hey, when h is equal to 11, but you know, because you're solving a quadratic, what does it have to equal? 0, so you got to get that constant on the other side. So let's go ahead and subtract off the 11 from both sides. That's going to go to 0. This right here is going to go to what, 12? Can rewrite negative 16t squared plus 27t plus 12 is all equal to 0. And you know what? I don't even want to be thinking. How about we just do A, B, and C, and let's use our quadratic formula to go ahead and factor this guy. Notice whenever you put this in to the formula, it looks like this. It's going to be negative 27 plus or minus the square root of, remember when you're placing a negative inside your calculator, you need to wrap it around parentheses, or else your calculator will give you a positive number or a negative number, and you don't need to do that. Minus 4, my A is negative 16, and then I have a 12 times 2, negative 16 is going to equal a negative 32. When you get this down to a little bit more of a simplified form, it's going to look like this. Negative 27 plus or minus the square root of 1497, and then divided by negative 32. Okay, so remember, you'd put that in your calculator, you do negative 27 plus the square root of that number, and then divide it, and you're going to get a number, right? But then you got to do it again because you have that minus in there as well. Because you're going to get 2 answers. How do I know? Quadratic, there's 2 answers, okay? You might be saying there, go, but what about the ones that have x plus 3, you only got 1 answer. Did I? There was still 2 there, but I only counted 1 of them, right? Okay, so look at this carefully. Whenever you do the math to this is what ends up happening. You get h is equal to negative 1264.30 or 2.05. And let's be honest, which one are you going to use?
2.05.
Why would you use 2.05 and not the negative?
Because you can't have a negative distance.
How are you going to throw a rock and it go back in time? Does that make sense? Okay. When you see the notes, I drew you a pretty little picture with a little smiley face up there so you can kind of see what's happening. See? And there we have. And like I said, the ones you saw me skip on here, don't stress out too much. Remember, my notes are going to be downloaded and you can look through those. Good news is today's lecture was recorded, so it will be downloaded. I will try in the next few days to try to get some other little things out, but my notes are there for 1.6 and 1.7. They're probably just as good as the videos, I think, sometime. Okay. We will finish up 1.9 tomorrow. That means your chapter 1. Hey, your chapter 1 test still isn't due till next week. Okay, it's not due till next Wednesday. But remember, after next week, things will revert to their original schedule where things will start happening on chapter tests will happen on Sundays. Okay, this week, we're gonna go ahead and start chapter 2, okay? So that way, we've got a little bit of a buffer, okay? You'll at least have a 2 or 3 day buffer between some homeworks. That's what I'm trying to do, okay?
Have chapter tests online?
Oh yeah, chapter tests are all online. You got 3 chances to do them. And everything now. And hear me out, because a lot of you, if you've taken me before, then this is a taking paper test. I do online test for this class. Okay. How I do it is this. You get your chapter test done on time. Okay, if it's late, you don't get this reward. Now I will help you. I'm gonna pick on her. Let's say, I think I give you 3 chances and you gotta make above a 70. But let's say she uses up all her chances. Well, you're not stuck. Okay, because it's not gonna open the next homework until you do that chapter test and get at least a 70. Email me. I'll open it back up. Okay, that's no problem. I just cap it at 3. Okay, I'll open it back up once in 24 hours. Okay, so if you ask today, I'm gonna be like, hey, and then if you email me again, go, man, I failed again. Wait 24 hours, and then I'll open it again. You can go back in and study what you miss on these things. So I suggest studying what you miss. It's gonna help you out, I promise, okay? So that's just how those work. But here's my little promise to you. Let's say she gets it done, whatever, after the due date, okay, which next will be next Wednesday for your chapter 1. On Thursday, I usually go in there and I look at everybody and go, okay, all of y'all did it because you're gonna do it on time. You made a 75. You made an 83. You made a 71. I'm gonna go through every single one of them and look at it. Because Hawks is a computer, let's be honest. Sometimes you put in the right answer and it's like, that's wrong. Maybe you put a space in there and you shouldn't have. Okay. I go back in, I try to give you partials where I can. So I will adjust those grades accordingly. If you don't see any adjustments, that means you didn't get it. Okay. But that way you can kind of look at it. Okay. All right, guys, I'll see y'all tomorrow.